when the noise is excessive. This is something that we'll say it's a workplace hazard. It's something that happens over time as well. And the thing with noise is that from the engineering perspective, from the engineer's perspective, it's something that you can measure. And that's what it is that now gives the engineers the key to say, okay, we should be able to control it. And that means assessing what exactly should be a tolerable noise level and then keeping it there. Also, because as humans, you can tolerate loud noises for periods, say temporary periods. Again, that is something that can be measured, and then what engineers look at to say, okay, what is it that can be done or should be done? With brief loud noises, you may be able to recover. Your ears will bounce back. It can be affected, but by what's called fatigue, but it can come back. But if it's something that is really sharp, it will take a while. You may get tingling in your ear, but if it is something that is really sustained, it will be permanent hearing loss. And when it is lost, it is gone. So that's something that engineers try to control so that the workplace hazard will be reduced. Other harmful effects of noise, it ultimately eventually leads to hypertension. Just having that noise, some people who have found that they get that ringing in their ears or in their head, and palpitations, and they are not able to sleep. So the noise sources I've shown in the pictures earlier, it could be from airplanes, it could be from vehicles, it could be a person's place of work, it could even be the generators in the area. All of these are noises. So what is it that the engineers will say is tolerable and should be controlled? What the engineers have assessed is that for a person that is working in an industrial workplace, 8 hours exposure to 90 decibels is what it is that will not cause permanent, irreversible hearing loss. And this is 90 decibels, and this is at 1 meter. So a generator, for example, that is soundproofed. That's the kind of thing that engineers will look at and say that if you've got an engine or any source of loud noise, you need to keep anybody that is at 1 meter at 90 decibels so that he will not have permanent hearing loss. And also, I will say for those ones who are business owners or the managers of workplaces, that whatever it is that they are doing that is going to cause loud noises, you can use an audio meter, a sound meter, to measure how much noise does that equipment produce, how long is it going to operate for, and how much exposure will it give to workers. This is what the noise levels are. So what engineers do is that they try to control the noise, either by reducing the vibrations that cause the noise. So noise is really about a surface, a large surface that is good at amplitudes that move that create sound. If you're able to reduce the vibrations, you will reduce the noise. So that's one of the things that the engineers do. They try to reduce vibrations, vibration control or padding, to be able to reduce the noise. If that doesn't work, or if that is not practical, it will be to enclose the equipment, cover it around, put in a building, create a shell around it, and put soundproof panels to be able to reduce the noise and the thickness of the material. We've said what the noise level should be the thickness of a material should achieve that reduction or sound attenuation. If the equipment is too big for that, it's just the whole area, then the engineers will consider enclosing the operator instead. If you can't enclose the equipment, put the operator in a soundproof enclosure so that the operator will be able to stay for those long working hours to be able to work. Or if that is not practical, then move the operator away from the noise area. Let the operator be working from a remote location and be controlling the equipment or the operation remotely. This is, again, what engineers do. Another thing that engineers do is use PPEs. PPEs like the earmuffs that will enclose their ears. And so this is not just ear plugs, but earmuffs are also for enclosing or protecting the sound and reducing it. So that's another example of a physical hazard. Aside from vibration causing noise, vibration also has its own hazards. So vibrations, particularly for those ones who are maybe in construction industry or industrial environments, factories, vibrations have their own hazards. They have their own effect on people as well. And vibrations, they can cause blisters on the fingers. For those ones who have used jackhammers, they will know that the effect, if you use it for quite a while, is something that it turns your fingers numb, and it's actually because it's shaking the blood vessels, and then blood is not flowing so well anymore. And eventually, you even have like some kind of tingling. You're not holding the jackhammer anymore, but your hand still feels like it is vibrating. And so these are, we'll say, hazards that happen if you're holding a vibrating equipment, or if you're even operating a equipment like earth moving equipment that causes vibration. It also gives whole body vibration effects like fatigue or irritability and disorders of the spine. For those ones who have to work on this, that this is just their work schedule, what do engineers do? Well, what engineers do to be able to reduce the hazard. So in terms of let's say procedures, in terms of policies, continuous working should be avoided. That's one of the most simple things. But then there are also tools that are built to be able to prevent that hazard. So there are anti-vibration tools that can be specified, that for those ones who are going to be working for long hours, that to use anti-vibration tools or anti-vibration gloves. These are heavy padded gloves, so they can absorb the vibration. Anybody that is going to be using those equipment should have those gloves there. These are not thin gloves or surgical gloves. These are gloves that are meant for working with that specific type of hazard. So these are things that can be done. Other types of education is using safe working practices or education on how to use those things. I'll talk about lighting as well. Lighting is also a hazard that engineers also have to look at. It's a hazard because, for example, when it is poor illumination, you get eye fatigue. Your eyes start getting heavy, it's painful, you get headaches, and then your eyes start watering if you do not use appropriate lighting. So working in a dingy environment, in a factory with low-level lighting, in an office that has insufficient lighting, in the long term, is something that creates these health hazards that are physical. On the other side of the spectrum is when the lights are excessive, when it is too bright. It it starts affecting your eyes. And this is also something that for many people has become more, I'll say, topical. People who stay at their screens more since COVID had caused more people to do more of virtual meetings. A lot more people have been staring at their screens, and sometimes the brightness is something that they have not noticed has been affecting their vision, and more and more people are reporting that they need to use glasses, and some feel that maybe is that they are getting older. It's now old age that is coming on, but again, it could also be it's the lighting that is affecting them. But then all of these things are hazards that engineers recognize. So what is it that engineers to be able to control it? What is it that the designs, what is built to help it? Well, the thing with light as well, like everything that engineers are comfortable with, is that you can measure it and then say what is the appropriate level of lighting for a specific working condition. So if there is a working area that needs a particular level of lighting, it would just be to specify and to install lighting that is sufficient for that level. And in terms of level as well, the lighting, depending on maybe how high the building is, where the light sources, you can also increase the intensity depending on how high you want to put the light, or if you want to lower the light so that it will be closer to the working surface. There are different types of I would say lighting areas, and this is just an example of what it is that recommended lighting levels are. So the kind of light that is required for, if it is a security light in the outside, it's just general yard. It's soft lights that you need. You don't need very intense lights for those things that are you just say is walkways, etc. If it is a work area, though, you need to increase the light intensity, because you want the workers to be able to see it better without tightening their eyes too much to say, what is this? You need to increase the light. And if it is, for example, indoors and it's on a workbench, somebody is going to be doing machine work, you need to increase the light to be also appropriate for that. And the lighting that you'll say will be the most intense will be for those ones that are doing very fine, detailed, precise work, and they're using small parts of equipment. You need to get as much light as possible so that they can see what it is that they're doing without creating those issues that we had talked about. So those are the things that engineers do to prescribe the right type of light and to design how it will fall on the surface so that it will reduce that kind of hazard. Other types of lighting, so we talked about lighting that we'll say is general, but there's also the lighting that we say affects the eyes, and the ones that affect the eyes for many people, we've said to reduce the screen intensity, some people will put an anti-glare screen, so a screen cover to be able to reduce the strain on the eyes. The lighting is also a form of radiation, and there are types of radiation that we can also create hazards. There is what is called ionizing radiation and the non-ionizing radiation. The non-ionizing radiation is ultraviolet, is one that is visible. So welders, they many times they have radiation that can affect the eyes, and so if you have to weld, you have to do something about that to be able to protect the welders so that they do not damage their eyes, or those ones who are around them should not damage their eyes by looking at. And then the ionizing radiation are the ones that are like X-rays. Those ones, they cause more than just damage to the eyes. They can cause damage to the person, the body. The blood can cause anemia, can cause leukemia or cancer, and X-rays are particularly, or can be particularly dangerous. They're all kinds of sources of these kinds of radiation, and I'm sure a number of us will remember when there were talks about 5G telecoms being introduced, and there was a concern that will that not create radiation, and there was I would say general panic that maybe to prevent it. But as engineers, understanding what radiation is, engineers can state specifically what the hazard is, and then what can be done to control those hazards. So the low frequency radiations, they do not cause that kind of, we'll say, bodily damage, but somebody needs to mute. And the ones that are the higher frequencies, gamma rays, those ones people are harmed by those ones. So those ones, engineers, again, we create similar to what we had said for the physical hazards, that either you block it by containing it, or you shield the person, or you use PPE that will be able to screen out that radiation so that it will not harm the person. I'll also quickly talk about other types of hazards. So I've talked about the physical hazard. I'll talk about chemical hazards. What engineers do about it? What is it that constitutes chemical hazards to we'll say to the technical people, to engineers? What we'll say are chemical hazards are things that are, we need to mute more people. So the things that can, we said, cause harm to the body, changes to the body. So it's not biological. We say this is chemical. So like dust, like smoke, like fumes, even gases or acids and alkalis. All of these are things that we will say are like chemical hazards. And what they do, again, for an engineer to be able to say what he'll do to control it, is to just understand what it does to the body, and then we'll say we're designing, and then we're building, and then we're operating or maintaining what it is that will cause this. These chemical hazards, they're agents that can enter our body and then cause problems. So it can enter either through our skin, or through our nose, or through our mouth. All these, I said, particles or foreign agents, these are things that they can cause skin disease, lung disease, or other internal diseases. But by understanding this as well, we also understand that it can even be organic or inorganic. The organic ones are things like cotton, like plants, like jute. Inorganic things are things like silica, asbestos, coal is a big one. And these types of, I'll say, dust, we've said if it's for people who have to work in, maybe it's a factory, in the production plant, where there's a lot of these types of dust, when they are insoluble, they coat your lungs, and then they block it. If it is something that is soluble, well, the body hopefully can handle it. But when the thing is plenty and is thick, it shortens the we'll say the life of the person in the work environment, because when it enters the lungs, it just blocks it. It reduces the breathing capacity, and the dust particles that we're talking about. So typically, our nose should be able to filter out big particles, but when it's fine as well. So in maybe it's a flour milling industry, cement industry, coal. All these things they get into the lungs. The bigger dust particles, we said, when they clog in your throat, sometimes it just blocks, and then all of this causes a person to reduce their productivity. And so these are hazards that as engineers we try to control. So what is it that we do? So for any environment, work environment, industrial environment, there are big efforts to be able to control the dust, to reduce the emission of the dust, whatever that dust is. So whatever those fine particles are, we've said it's a big thing to reduce it, because we know it will cause problems. For some, it's putting like some kind of a wetting mechanism or water spraying to be able to tamp it down, or it's also ventilating the area so that it does not plug the place. That may mean creating exhaust, putting exhaust fans, and sometimes some people just allow it to plug if there are filters as well. It may mean enclosing whatever it is that our equipment or apparatus is. So this is one of the first lines of attack against dust, is about controlling it. And a second approach will be personal protection, which will be for the individual: nose masks, face masks, appropriate clothing, boots, barrier cream so that it doesn't enter into the skin, and also encouraging, and again, this is about behavior, personal hygiene, or health education. The medical control also involves periodically checking what the level of damage can be, so as to know whether the harmful effects are still bad or still ongoing. But this again is what it is the engineers will do for the chemical hazard. So yeah, just like dust, smoke is also something that similar to what it is I've said, chemical hazards, or fumes from other liquid chemicals. And the approach to taking it is to control it, to first of all suppress it, to eliminate it, to mitigate it, and then putting other measures in place to be able to control what the health impact is. Same thing for vapors. So for those ones who work with chemicals that are liquids, again, the kind of approaches that are taken to be able to engineer a safe handling of those products is something that is similar. Poisonous gases are those ones are also chemicals, and those ones will be see on the end of the spectrum as well. For those ones particularly, nose masks, gas masks are built to be able to handle those things. So for chemical hazards prevention, again, knowing what the chemicals are, knowing what it is that they do, knowing how it is they get into the person, will help to be able to control it, and also studying what that plant does, how it generates those chemical agents, and then being able to isolate it or suppress it at specific points, and then being able to mitigate against it, and continuous education of the operator, training, putting together policies in operations manuals. That also helps to present it. The last set of hazards I'll talk about will be mechanical hazards. Mechanical hazards, again, because we are in I'll say in an industrial world, there are lots of equipment that we are using, labor-saving equipment, and everybody takes it for granted. However, having so much equipment could also mean that we start getting complacent, and if we have crowded workplaces, we start lowering our attention and the bar of safety, and the equipment themselves. They to an engineer, they're almost like they too, they have their own personalities, and if they are not taken care of, they can get upset, and then they start acting up and quote unquote retaliating. So if they're not properly fixed, if they're not properly maintained, if they are worn, they would misbehave, and it won't be because they were not designed to do that particular job. It's just that they were not properly taken care of. Though that doesn't also rule out the fact that there are some, when it comes to designs, dangerous parts, pinch points, things that are clearly hazardous. So these ones are things that they cause mechanical hazard. So what is it that engineers do? Well, those hazards, we know where it is that they come from, as in if a safety engineer, so we've said engineering is because it's equipment, all of us are using equipment, but the safety engineer also looks at what it is that creates the hazard, and at the point of operation, certain operations create hazards, are inherently hazardous. Cutting, shaping, drilling, stretching belts, they're inherently hazardous. So when a safety engineer is looking at it, he can just do an assessment and say that he knows that this kind of thing will cause this kind of safety hazard. So something has to be done about it. So flywheels, pulleys, cams, gears, conrods, couplings, chains, belts, all of these things, they cause the hazards, like I have shown in the pictures there. So what is it that engineers do? So another example is abrasive surfaces that they are a hazard when you touch them. What do engineers do? Well, what engineers do is they put guards. That's what engineers do. They put guards. That we know these equipment are needed. We know they have to work, but it would be to put a guard and make sure that the guard stays there, that is fixed. There's some equipment as well. If the guards have to be opened, they have an interlocking mechanism so that it will make the equipment stop if the guard is removed. Some people don't understand why, and so they disable it and feel like it's just disturbing. They just wanted to quickly open the guard, take out something, and then want it to continue. But really, it is an engineering protection for to reduce the hazards. And these are also some of the things that are also done to be able to protect against mechanical hazards, creating a physical barrier, a mechanical barrier, so that the individual is not hurt. So these are I'll say the main things that I just said I will share. In preventing hazards, what engineers do, try to control the problem, do designs to control that problem, to reduce it, to make sure that everything is safe for individuals so that they can work. And again, is to say that for occupational health and safety, at least for this general audience, this is what safety engineers do. And I hope with this, I have been able to share from our perspective how it is that we are all part of that one big happy family. Thank you very much, and back to Diwaliu or Dr. or Engineer Saiki. So I do not hear Anyone?
Yes, sir, we are with you, sir.
Okay, thank you very much. All right, then. So on that note, if there are any questions, I will be happy to take them. See, Happy Udo Nse. Happy?
Yes, good evening, sir. Okay, my question is, can you hear me, sir?
Yes, you can, but you're breaking off.
Okay, that is as a result of my network over here. Maybe I don't know. Maybe you before I joined, maybe you might have explained that because I was just watching and listening to the presentation slide and all you presented about engineering safety. To ask, with somebody with maybe an economics or accounting background, then decided to go and form local and international certification for health and safety. I'm looking at it in practice, even at the workplace. All the team mentioned, I'm not seeing anything outside the job role regarding as an engineering safety, as we have mentioned. So I just I want you to throw more light with somebody in economics or accounting, then getting some certification in safety. How do we call such a professional safety?
Okay, thank you very much, Happy. So yes, I had talked about it earlier. I'd tried to talk about those who are safety professionals, and I said that safety professionals, we have all kinds of backgrounds. That there are those ones who are safety, that they're health professionals, like who are clinicians, doctors, nurses. They are HSC people. An economics person is not a doctor, but that doesn't mean that it is only doctors that are HSC professionals. And there are also other safety officers. They all have their various roles. I today was talking about safety engineers, and wanted to see what safety engineers do in the world of HSC, and that is what I wanted to share. So your certifications, and I'm sure it will all be valuable in the safety world, that you'll be seen as a valuable safety professional. I hope that answers that. I see the next one is Darlington Hezekiah. Darlington.
Okay, engineer, good afternoon, sir. Or good evening. Good evening, everybody. Can you hear me?
Yes, we can. Good. Go ahead, Darlington.
Okay, yes. So my question is, when you were talking about the noise level, okay, so you have some noise limits that you presented. Okay, so looking at the NESTRA noise regulation, which took their noise limits to equivalent continuous level. So looking at what they have on the NESTRA and what you presented, I'm thinking when they were coming up with these noise levels, is it that the engineers did not make any input as regards to the level? Or how did they come up with all this? Because some buildings, they, in the day, in the night, there are different noise level that they have put in.
So I will say that what I showed was an example, and it was the example from India. So it's not saying that that's one for Nigeria. This was just saying it was an example that engineers look at the noise levels. There's an approach to controlling the noise, to engineering a safe environment. And so it's not replacing that of NESRIA. This is just simply saying that this is what engineers do. So I'll say standards for Nigeria, the standards for Nigeria, will follow the standards for Nigeria. And the ones I showed were an example from India.
Thank you.
Okay. Thank you, Darlington. I see Caleb Sunday's hand. Caleb Sunday, do you want to unmute yourself? Okay, maybe that was done in error. Temidaya Williams.
Good evening. Good evening, sir. First of all, thank you for the nice presentation. And to Mr. Wali, thank you for always making sure that we are having this kind of discussion always. So my question will be very direct in the aspect of legal. So as a safety officer where I work, we did the periodic noise test for workers, and on review of the results, majority of the recommendations given by the practitioner was to, for some of the workers, we had to eliminate them entirely from noise exposure. Now, as a safety professional, as a safety officer, I liaise with my manager, talk to him about this and the legal aspects, the implications of it if we do not go as per the recommendation. Now, what do I, as a safety officer, do when such recommendations are not implemented? What can I do in that kind of angle? The second question. Hello.
Please go ahead. There are a number of people that have unmuted that we need to mute them.
Okay, did you get the question?
So if I can summarize what I heard, it was that there was a noise test done for people in your area, and the recommendation of the consultant was to remove the people who had been tested entirely from the premises, and that you had taken that to a superior, and that recommendation was not accepted. Is that a correct understanding?
Exactly.
Okay. All right. So what I will say is that safety professionals are safety professionals. Management is still management, and we do need to make our recommendations. And we can't stop making those recommendations. Let me quickly share something on the screen now and see. Can you see my screen?
Yes, sir.
Okay,
yes,
all right.
Sir.
So this is what is called the hierarchy of controls when it comes to, I'll say, in safety engineering. Well, so for safety professionals, typically, but this is how we look at it. That if there's a problem, the first thing is to remove that problem. That's the first thing, to remove the problem. That's the most effective thing. Any problem should be removed. If it cannot be removed, then it should then be, what is it that we can do as a substitute that will not cause such a problem? Is there an alternative way of doing that thing that will not cause a problem? Then the third thing is doing a design that will be able to either eliminate the hazard or isolate the hazard or insulate the hazard. And then the next best thing is continuous training, work education. It's awareness, and then after that, it's administrative controls, policies, specific policies. So PPEs is the least effective. It doesn't do anything about the hazard. It just tells the people that I'll try and take care of yourself more. So for the people it is that you have talked about, there is, I understand what you said, there's a source of noise in a noisy environment. Their hearing is starting to get impaired, and it has been recommended that maybe their hearing is going to be permanently damaged if they are not removed. But I would suggest that take this kind of thing to your management and tell them these are the options that they should take. Usually, management will say if it is just one option you bring, it's a yes, no, it's binary decision. And many times if it's not something that will bring money, they'll say no. But if you come up with several options and say, this is what can be done, they can then assess it and say, okay, which one is the least cost to them? And then they may be able to say, this is what it is that they'll do. For the people, I don't know what the nature of the job is exactly, why it is that they would ignore that recommendation, maybe to be losing them a lot of money. But if they do not remove the people, then they, for them to continue to work safely, you may want to talk about, ask them that they should build an environment that will keep them safe. If they feel it is too expensive to build that environment that will keep them safe, then they will feel like it's cheaper for them to say, let them replace those people with other people who will be able to work all again. We've said maybe it's even PP that will provide them, but I would suggest that go through with your management what the options are so that they can see what kind of I would say informed decision they will make that will be able to promote the safe operations and the safety of the individuals. I hope that helps.
All right, thank you very much.
Okay, Engineer Emmanuel Okudo, very nice to see you. Please go ahead. Emmanuel Okudo, you want to unmute yourself?
Okay, good evening. Good evening, sir.
Okay, it looks like Obong has jumped the queue, but okay, Obong, go ahead.
Okay, good evening. Thank you for the nice presentation. It's been very enlightening and eye-opening. I want to ask, please, how do I studied electrical and electronics engineering, and I'm in the safety profession right now. Can that actually make someone a safety engineer?
The answer is yes, absolutely yes. So the Nigerian Institution of Safety Engineers was set up as a division of the Nigerian Society of Engineers, specifically for engineers who are working in safety. Safety is a very big gap in Nigeria, and the Nigerian Society of Engineers had said that, and again, this was because of public outcry, that what are engineers doing? Nigerian Society of Engineers said all engineers who are in safety, let them come into this division so that they can put a clear focus on safety. And again, like I said at the beginning, it's about technical safety. If you're doing something that has to do with safety and you're an engineer, you'll be absolutely welcome to register with the Nigerian Institution of Safety Engineers.
All right. Thank you very much, sir.
You're very welcome. So I see Francis Agbola.
Yes, sir. Good afternoon, sir. Thank you very much, sir, for the nice presentation, sir. Hello, sir. Can you hear me, sir?
Yes, I can. Please go ahead.
Please, actually, sir, there's something I want to ask, sir. Let me start myself as an example, sir. Though actually I study accounting in university, but I'm a fire safety. But my profession now is a fire safety. I deal with little sales, some training in line of safety. But I also have little idea, regarding safety. But my question, what I want to ask is that, aside from, sitting from professional exam, acquiring more certificates, actually I'm an entrepreneur to be precise. But, yeah. So what kind of opportunity that people that are entrepreneur, that are not working for companies, how can someone really be a safety engineer? Please, I just want you to just, enlighten or throw more enlightenment on that. Because I'm citing myself as an example. I really have keen interest in safety. So I try, I do attend conference and some other thing like that. But I'm an entrepreneur, but I've not had the opportunity, to practice it. What I mean by that, maybe, working for an organization, maybe regarding, as a safety officer or whatever. How can someone like that have that kind of keen interest, in safety? How can that kind of person, work on himself more? Because that's what I want to ask, sir.
Okay, thank you very much, Francis. As entrepreneur it's an excellent thing. Entrepreneur will mean that you're working for yourself, and it's something that I think for Nigeria we need more people that will work for themselves and create employment for others. It will help to reduce unemployment. What can entrepreneurs do in safety? So I'll speak from the point of view of, I've said the technical safety. I've said there are other areas of safety that I would not be competent to venture into, if it's about health or such things. But if it is technical safety, going by what it is that I had shared, it's possible to be a vendor for equipment that helps for technical safety. Engineers, they will design it, they'll build it, but somebody has to produce it and then maybe sell it and share it with organizations. So this is something that as an entrepreneur, you can just look at what is it that you like to position yourself to do. There are quite a number of entrepreneurial organizations in Nigeria that are into HSC. They sell PPEs, they sell fire extinguishers, they sell fire suppression systems, and they are not that. So in Nigeria, we don't have that many big companies that will do fire tenders, etc. So it's something that I'll say you should be able to find something that will be well, that you can really excel at when it comes to that. I hope that helps. Emmanuel, kudos hand has come again. I hope you'll be able to unmute this time. And I'm also keenly aware I'd been given 30 minutes. I tried to rush through it but I don't know how much more time the organizers would have. But Emmanuel, please go ahead.
Yeah, good evening, Dr. Shehu. Quite a brilliant presentation. I don't know if I will be allowed. Mine is just a short contribution.
Please go ahead. Okay, Emmanuel, you have somehow inadvertently muted yourself.
Hello?
Okay,
Hello?
I can hear you now.
Hello?
Please go ahead.
I said mine is contribution. Okay.
Please go ahead. Hello, Emmanuel.
One, I want to. Can you hear me now?
Yes, we can now.
Okay. Yeah, I want to contribute regarding the engineering aspect. Basically, in terms of operations, plant operations. One, for valves, for pumps, right from inception, is very important. We design for vibration, and that's why when you go to some facilities, you will see some dampers, okay, along the line where we have the pumps. And what that does is to cushion that vibration effect. And they put also vibration sensors in terms of monitoring the frequency and how severe this vibration is. Because vibration of time have led to failures of seals in pumps, and that will lead to loss of containment at some point in time. When attention is not, when operators don't respond fast, and sometimes it leads to fire. Again, an additional one is fireproofing. And sometimes you have issues with nearness of some critical safety equipment, like separators, compromising, sighting, and in terms of distances. Yeah, so when that happens, some of the things one can also do is to fireproof the legs, which are the supports. So these are just few ones. There's a whole lot that engineering and design need to take care of, yeah, right from the design of process facility. And that will go a long way ensuring safer operation. Thank you.
Thank you very much, Emmanuel. Excellent contribution. It's like I said at the beginning, I didn't want to go into the technical details. So the safety has to do with people and the assets. And Emmanuel has talked about how it is that these hazards, they also affect other assets or facilities in an environment. I have spoken about how it affects health or people quite a bit, but what Emmanuel has said is also very key for safety engineers. They look at the technical safety, what is the impact, and it's a very wide field for anybody that would like to be in safety engineering. I can assure you it's a very exciting field that we would really be happy that more people join. I don't know how much more time we will have, but there's still 3 more hands: Julius Wambete, Caleb Sunday, and Maxwell Ejogu Oriaku. So maybe we'll just cap it at those 3. So Julius Wambete, please go ahead.
Thank you very much. I'm called Julius Wambete from Uganda. My question is brief. What are the requirements for someone to join that association of Nigerian safety engineers? Can someone from outside Uganda join, or it is particular?
Well, I would say that there is no restriction in terms of the nationality. Because it's a division of the Nigerian Society of Engineers, it means that primarily those ones who are qualified or recognized to practice as engineers in Nigeria will be immediate candidates, and they'll be automatically eligible. But the Nigerian Institution of Safety Engineers also registers those ones who are not engineers as either associates or affiliates. And there's no restriction in terms of the geography. So if you want to join the community of practice in Nigeria and you want to register, you will be very welcome. We'll be very happy to have you. I hope that helps, Julius.
Yeah, correct.
All right, thank you very much. Caleb Sunday.
Okay, good evening. So can you hear me?
Yes, we can. Please go ahead.
All right. My question is, like, you advise a safety professional, occupational health and safety professional, to get some certifications to be a recognized practitioner like NEBOSH, ISPON, and all that, and also become a member of IOSH or ISPON. What would you say for a safety engineer that want to be fully recognized, that want to have the required certification as a safety engineer?
So the Nigerian Institution of Safety Engineers, it was newly formed, and so maybe awareness is not so great. But the institution is trying to develop a professionalization, deepen professionalization in safety engineering, and so it also does training and is developing also certification in conjunction with other safety bodies. So other safety bodies, so ISPON is a lot of engineers who are in ISPON are also in the Nigerian Institution of Safety Engineers. In fact, the pioneer national chairman, the current national chairman, the immediate past national chairman, they're all members of ISPON, and quite a large number of the current executive members of ISPON. They're also members of other safety professionals. So I'll say that for engineers, being a part of the Nigerian Institution of Safety Engineers, joining the community of practice will also help to, I'll say, get the training that will provide and what it is that you're looking for, that kind of professional recognition. The NI Safety is also working with COREN. COREN is the Council for Regulation of Engineering in Nigeria, to get that recognition for anybody that is registered or certified, to be able to get in the workplace recognition. The Nigerian government has just recently said all MDs should have a safety officer, and for those ones that are in technical positions, we will expect that as engineers that they would also be part of the NI Safety E, and hopefully COREN is going to try and ensure that more people who are appointed into responsible positions of safety are properly trained and certified. So that's what it is that I would suggest, that whatever professional associations that you may have been, or certifications, NEBOSH, or associations like ISPON, IOSH, etc., that the NI Safety works with all of these ones, and is a part of what your career trajectory will be. Okay, I hope that helps. The last person will be Maxwell Ejugu. Maxwell Ejugu, would you want to unmute yourself?
Hello, good evening, sir.
Good evening.
Yeah, I want to ask a question. I'm speaking from Qatar. I want to ask a question on behalf of a friend.
Okay, go ahead. If you say you're speaking from Qatar, our mind will immediately go to the stadium. That are you there to watch football? Are you rooting for Morocco? But go ahead. You can ask a question on safety.
Okay. What I want to know is that I have a friend who don't have a degree in engineering, but have a O-level and the national diploma, and have acquired so much experience in safety and international certificates like IOSH, OSHA 30 hours in construction and general industry, IGC, NEBOSH IGC, MVQ level 6, and the NEBOSH international diploma. So what I want to really know is that because of we are talking about safety engineering, what will be the hope of such an individual concerning or becoming a safety engineer back to Nigeria?
Well, thank you very much for that question. I had mentioned that the Nigerian Institution of Safety Engineers was formed by the Nigerian Society of Engineers, but it is really about safety. And so there are non-engineering professionals that are also registered as affiliates and associates. We talk about technical safety. So if a person is experienced and wants to do more about technical safety engineering, then they're absolutely welcome. We do lectures, we do different safety lectures at the annual general meetings. We also, at the conference, we have different lectures as well, and it helps to deepen the knowledge and the capabilities of those who are involved in technical safety. I think either last year or 2 years ago, Emmanuel could also give a lecture at the AGM in Warri, I believe. This year we had a conference in Lagos at the Radisson Blu Hotel, and it was also very informative and very enlightening. Safety is a very, very wide field, and anybody that is involved in safety, you can't say you've known it all. In one of my opening slides, I said that it's in practically all the areas of endeavor that you'll find safety, but there are not so many people that are into technical safety that really know about technical safety. So if you come, you can join, or your friend can join the association, so that he can learn more about what we are doing in Nigeria about safety. And the people that talk, they are usually very knowledgeable people, very well informed. They're talking about what is the cutting edge and where technology is going. And I'm sure he will benefit from joining. I hope that
thank you very
will
much.
help. Thank you as well.
I would like to get more information on how to join the association.
Absolutely. So there's a website, the nisafety.org. There's a website, nisafety.org. There's the website, NISAFETYE. NISAFE. Yes, nisafety.org. .org. So yeah, so you can just Google it. You will be able to find it. On that note, I want to say thank you very much. It's been very engaging. I have taken more time than I was asked to take. I appreciate your forbearance. Thank you very much for paying attention and giving me the opportunity. I will now hand over back to either Waliu or Psyche, Engineer Psyche.
Okay. Good evening, everyone. I'm using this great opportunity to thank everybody who has found their time to be present on this Zoom call. Today, we have talked extensively on an overview of engineering in safety and what safety engineer does. And many of us that came from different backgrounds, and I'm sure we all have learned various engineering controls that can be put into place in our various places. And we still want to thank let me say the lecturer, because the webinar has been engaging, it has been splendid, and it has been interesting. So we want to say a very big thank you to Engineer Sheung Faluyi, sorry sir, a fellow safety engineer, and we highly appreciate your coming, and then we highly appreciate your wealth of experiences, and then for teaching us what we need to know regarding engineering in safety. And also, I want to thank all participants ranging from Darlington, Iska, Gabriel, Anthony Effiong, Atoloye, Fadilat, Motunrayo, Bakare, Situan, Caleb, Sunday, Christopher, Daniel Vogt, Efe, Okono, Emmanuel, Adeyemi, everybody who has found time to be on this call. We thank you. On this note, in the absence of any question, then we are going to call it to an end. Thank you.
Thank you, Daniel. Thank you, Engineer Sheung.
Thank you, everybody, and enjoy the rest of the day.
Engineer, I wanted to say something before you go. Engineer, we are yet to get the conference slides, as promised during the conference. Yeah.
Right. So the conference slides are available on the website. Okay. I hear they've been posted to the website. So please check on the website. If they're not there, then please send a message. And but the understanding I have is that they've been uploaded to the website.
Okay, except recently because I checked some time ago. All right,
I will follow up on that. All right, you're welcome.
Engineer, sorry, sir, please.
Yes, sir.
I want to quickly, raise some view. I practice as a safety in a manufacturing environment, and you spoke about vibration, and so I was expecting, sorry to say that because in my facility here, when we are installing machines, because machines are installed in a building, and then when they are in operation, they generate vibration. So I was expecting, vibration pad being placed as part of engineering control under machines, be it generator, production machines, which can serve as shock absorber or vibration absorber during production of machines. And then it's also regarding chemical safety, sir, because I did chemical engineering, and then so we still love to ponder on material safety data sheets that come with each chemicals, because those documents, highlighted different controls, elimination, substitute. So the starting from engineering, if it is LEVs, putting eye wash, emergency shower, all those control as I've stipulated in the material safety data sheet and ILO standard. So I felt that one should also be dealt with. And then, too, again, sir, you spoke about particulate
matter, PM 2.5 and then PM 10. So I really appreciate that. And then, sir, lastly, sir, are you with me, sir?
Yes, go ahead. I can hear you.
So, sir, because many of us in the field came from different background of studies, some from engineering, sciences, medical, accounting, management, and co. There was a project and there is a need for we to understand the nitty-gritty of engineering when it comes to safety. I was working on a project with a team of engineers, and I was told, and most times they do relegate the safety department to occupational health and safety. And when they were doing the designing phase of this project, I told my boss, though my boss read mass communication, but I did chemical engineering. I told him, sir, we can be part of the designing phase since we have AutoCAD, right? Since everybody, the plumbing, the electrical, the civil guys are working, drafting on the design of the project. Then we said, oh, okay, safety tool can also use AutoCAD. Safety tool can also put and fire sensitive gushers, signages in that safety design, so that they won't just relegate us as if go and wear your shoe, go and wear it. And then two, again, designing of emergency exit doors, how the door must be open inward and what southward. So I felt this training is an eye opener for we to see the importance of inculcating engineering in safety. And trust me, sir, we really appreciate your presence and then what you have done for us thus far. Thank you.
Thank you very much, Daniel, for the kind words. I'm glad the session has been helpful. It was really to provide enlightenment that engineering is embedded in safety, and that it will be part of safety. The points you have mentioned, they are well noted as well about dampers for generators, industrial floors. Something that I mentioned was that I couldn't say it all. It would be impossible to say everything in just, I was given like half an hour, but I would say stole more than that time, but it's still not everything. But what you have said is very correct, and I would encourage to continue that line. About what you said about incorporating engineering into safety, that engineers are relegated. I totally agree with you. This is why it is that we're trying to promote the profile of safety engineers in safety. And what is done, for example, in oil and gas industry, that when it comes to design, there's what is called a hazard. That after a design has been done, there's a safety review to see whether there are any hazards that are inherent in the design and that should be eliminated by engineering. So whatever it is that in your factory they are doing, even if it's a mass comm person that is the safety manager, after the design is done, this is not saying you're taking over the design and doing the AutoCAD drawing. This is saying that you want to do a hazard review. That's the hazards in operations review, that the design has been done before it is actually implemented. Let the safety department review it, and then you can use your engineering skills to review it and see where it is that improvements can be made, where reinforcements can be done, where guards should be put, where controls should be installed, so that it will make it a safer design or a safer operation. So that's something that I will encourage, that you can take to your manager. I'm sure he will not object if you just say that let's safety review. It's not blocking or taking over or usurping. But thank you very much. Thank you very much for the kind words, and I wish everybody a good evening. The website is nisafety.com, nisafety.com, not .org. Thank you all very much.
All right, thank you very much, sir. Thank you, my powerful engineer. We really appreciate you. This was quite an enlightenment session. I believe that we have really learned a lot. On the call, we had more than 60 people who joined, and it shows that there is real attention when it comes to this kind of topic. And we hope that very soon we will have you again to join us and also enlighten us some other time. We appreciate everyone who has taken their time to be part of our event today. We appreciate you, Engineer Shem Palui. You are one of the kind. We appreciate you, sir. Thank you so much, everyone. Thanks for making it up to this moment. Thank you, Mr. Darlington. Thank you, Engineer Daniel Saiki, for helping us to coordinate today's training. Thank you, Mr. Francis. Thank you, Mr. Innocent. Thank you, Mr. Sonny Baragasi from India, always here. Thank you, Engineer Tiami, for being here. Thank you, everyone. We appreciate you. See you all again next week, where we have the last enlightenment session for the year, because by the time we have the coming week, that will be Christmas, and the coming one will be New Year. So next week will be our last enlightenment sessions for this year, and we hope to see all of us. Thank you so much. Thank you, Engineer Stefano. We can't thank you enough. Thank you, thank you, thank you. We really learned a lot from you today. Thank you, everyone. See you all again next week. Thank you. And